Okay, so you're going to find the component vectors, or velocities, sorry, over here. And so you would use the SOHCAHTOA and use sine of theta equals the velocity y over the initial over velocity, and then you'd have cosine theta equals Vx over velocity. And so you just rearrange the equation, so you would have Vy over by itself, and you'd have equals sine 25 degrees times 85 kilometers per hour. And so you'd get Vy equals 35.92 kilometers per hour. And you would do the same thing over here for Vx and get cosine 25 degrees times 85 kilometers per hour, and you get 77.04 kilometers per hour for your component velocities. Okay, so my fifth topic is motion in 2 dimensions, and that is when you take into account the velocity along with the time and the displacement and everything that we've learned previously, along with vectors, because vectors is the displacement and all that fun stuff with angles. So here are the equations we're going to be using. The vertical motion is delta y equals negative half of gravity, which is g, times the time squared. And horizontal movement is delta x equals the constant times the time. And Vx is just the initial velocity, as we decided earlier. And that's going to be my math for the equation. I said skydivers are jumping from a plane that is 100 meters from the ground and traveling at 27 meters per second in a positive x direction. The skydivers want to know when they jump out in order to hit the bullseye. That's my plane and bullseye. And so delta y is the 100 meters it is from the ground. Gravity is 9.81 meters per second squared, and the velocity is 27 meters per second. And you're trying to find delta x, which is the horizontal movement of the projectile and the time. So in order to find time, you're gonna plug it into this vertical motion equation and just rearrange it, and you'll get 4.52 seconds. And you'll plug that into your second equation for horizontal motion. And so the delta x is equal to 121.91 meters. Okay, so my sixth topic is motion at angles. And so my example is the Americans shoot a cannon off a 62-meter cliff, trying to hit the British 120 meters away, and the cannonball travels at 53 meters per second. What angle does the cannon need to be to hit the British, and how long will it take? And if the British move 5 meters every 4 seconds, will the cannonball hit them? So what I did is I found theta by plugging the y and the x into the tangent, and got 27.32 degrees the cannon needs to be pointed at. And then the time it takes would be 2.55 seconds. So yes, the cannonball will hit the British because they move in 4 seconds, and the ball will hit them in 2.55 seconds. Okay, so finally we have free fall for the last topic. And free fall is pretty much when the acceleration is constant. So like if you drop an apple out of a window or a bowling ball out of a window, the acceleration will be